Okay, hello everybody. Welcome back to your very last lesson of Algebra 2 Part A. So today we're going to talk about the fifth operation of functions, which is composition of functions, or it's sometimes called a composite function. So a composition is simply another function operation, okay? So a composition is the fifth function operation. So we talked earlier about addition, subtraction, multiplication, division. So composition is the fifth one on our list there, okay? And a composition is going to look something like this, okay? So all it is that we're evaluating one function using another function. So it's simply a function within a function. This is read as f of g of x. Okay, whoops, I don't know why I put a parenthesis there. Okay, so f of g of x. Sometimes you'll see it written, just because I want you to see the notation. I'm not going to use it, but it's written like this. So this is, some people call it fog. And the reason why I don't use this, and I think it's a terrible idea, is because a lot of times that starts to morph into what looks like a multiplication symbol, and then people think they're multiplying, okay? Those are two different things. So that's an open circle there, not a closed one like it is for multiplication. But just so you know these mean the same thing. But I'm always going to use these nested parentheses because I think it's less confusing. Okay, and the order matters, right? So f of g is a different function than g of f, okay? So let me give you an example and we'll talk about what we're going to do with this or how composition works. So let's suppose f of x is negative 2x plus 5 and g of x is 2x squared minus 1. And we're going to start by determining the value of f of g of 2. Okay, so what we're going to do is evaluate. If there's a number inside the parentheses here, then our answer should be a number, okay? So we're gonna start with this innermost function, whatever it is. In this case, we wanna know what is g of 2. So we're gonna start with that. So g of 2, we know how to find that, right? We're just gonna take 2 and plug it in for x in our function g. So just make sure you're choosing the right function, okay, to match whatever that letter is. So we're going to plug 2 in for x here. So we get 2 times 2 squared minus 1. So again, we're going to do exponents first. 2 squared is 4. 2 minus 4 is 8. And 8 minus 1 is 7. Okay, that's not our final answer, all right? That 7 just represents the value of g of 2. Okay, but I don't want to know g of 2, I want to know f of g of 2. Well, what I can do, since I know that g of 2 equals 7, is take this and put it in place of g of 2. So if I put the 7 in here, now all I have to do is evaluate f of 7. How am I going to evaluate f of 7? I'm going to take 7 and plug it in for x in that function f. So we're just using the appropriate function. If I plug 7 in here, then I get negative 2 times 7 plus 5. Negative 2 times 7 is negative 14 plus 5 equals negative 9. So f of g of 2 is equal to negative 9. That is my answer. You don't need 2 answers. You don't want 2 answers. Just that final one that you get after you make that second substitution is your answer. Okay? All right, let's try another one just to make sure. We'll use the same 2 functions, f and g. We'll just change up what our number is. So let's suppose this time we're going to determine the value of g of f of negative 1. Okay, so again, we said the order matters, so we've got to pay attention to that. So we're going to start again on the inside, right? So we're going to start by evaluating f of negative 1. So we want to know what our function value is for f if x is negative 1. So we're going to take this negative 1 and substitute it in to our function f. So -2 times -1 plus 5. -2 times -1 is 2. So 2 plus 5 gives us 7. Okay, again, 7 is not our answer, right? We're going to replace f of -1 with that value, which is 7. So what are we really trying to find? G of 7. Okay, so to find G of 7, we're going to take the 7 and plug it in to x in our function g. So 2 times 7 squared minus 1. Exponents first. 7 squared is 49. 2 times 49 is 98. And 98 minus 1 is 97. So we did it the other way. G of f of -1 is equal to 97. So that is our answer. Okay, so you're always going to start with the innermost function, substitute that value into whichever function is identified. Once you get that answer, you're going to substitute it into the other function, the function on the outside for that particular x value. And then the value you get at the end is your final answer. Okay? All right, that's not so bad. What happens, however, if the value inside the parentheses, or what's inside the parentheses, is no longer a number, but a variable instead? All right, so let me give you an example. Let's suppose f of x is 3x plus 1, g of x is x plus 2, and h of x is x squared. And let's say we're going to start by finding f of g of x. Okay, so if you want to try it, pause and see what you can do on your own. Otherwise, here we go. Okay, so in order to evaluate, we are going to do the same thing that we just did, right? Except that our answer, instead of being a number, is going to be an expression involving x. So we're going to replace g of x with what it's equal to, which is x plus 2. So f of g of x is just equal to f of, instead of g of x, we're going to use x plus 2. Okay, now, how do we evaluate f of x plus 2? Same way we evaluate anything. We're going to take what's inside here and replace x in this function f. So we're going to take x plus 2 and put it in place of this x in our function f. Okay, so if we do that, the 3 and the 1 are going to stay the same. We're just replacing this x with x plus 2. Okay, now distribute the 3. And we can combine like terms. So we get 3x plus 7. So f of g of x is equal to 3x plus 7. Okay, so you'll see then, again, since the inside the parentheses is a variable, our answer is also going to contain a variable. In the first ones, the value inside was a number, and so our answer was just a number. Okay, let's do one more of these we're going to use those same 3 functions. This time, let's find h of f of x. Okay, so again, the order matters, right? So we're going to start on the inside. I'm just going to erase these colors here so we don't get confused. Okay, so let's suppose that we're going to find h of f of x. So we're going to start by replacing f of x, always replace the one on the inside, with whatever that function is. So we're going to replace our f of x here with what f of x is equal to, which is 3x plus 1. Okay, so what we still have then is h of 3x plus 1. So all we did was take that f of x and we replaced it with the 3x plus 1 that it's equal to. Okay, now in order to find h of 3x plus 1, we're going to take whatever's in the parentheses, in this case, x plus 1, and we want to substitute it into that function h. So here's h. So we're going to take this and substitute it in for x here. So if we do that, we get 3x plus 1 squared. All right, this we just have to remember that 3x plus 1 squared, we're not just going to square the 3x and square the 1, right? We've got to multiply this out. This is really 3x plus 1 times 3x plus 1. So if we distribute the 3x, we get 9x squared plus 3x, and then distribute the 1, so plus 3x plus 1. And if we combine like terms, we are left with 9x squared plus 6x plus 1. So that is our final answer. Okay, so hopefully that makes sense. If you have questions about that or anything else, please let me know. And I hope you guys have a great week.